We are going through exercise 17a, and in this video we'll be answering question 1, which says let f of x equal negative x squared plus 4x. The graph of y equals f of x is shown opposite. We need to find the gradient of PQ. So let's come and look at our graph here. Here's P, here's Q. We're trying to find the gradient of that. So let's draw a line. So what we're doing is we're finding the gradient of this line. Now to find the gradient of something, the gradient, hopefully you all know that we go y2 minus y1 over x2 minus x1. Now let me call this right here. It doesn't really matter which one you call x1, y1, as long as you're consistent. And what I mean by that is I'm going to call this x1 and y1, and I'm going to call this x2 and y2. So these up here could have been x2, y2, and these down here could be x1, y1. It doesn't matter, as long as you're consistent. Having done that, now let's just sub some things in. So what I'm going to do is write this down, my y2, so it's negative 3 plus h squared plus 4, 3 plus h, and that's it. Then I'm going to minus my y1, which is 3, minus 3. Then I'm going to divide that by x2, which is 3 plus h, 3 plus h, and I'm going to subtract my x1, which is 3. Having done that now, let us clean this up a bit. So I have 3 and negative 3, so they're going to go away, which means I'm just going to have a denominator of h. Let's see if I can do that h a bit nicer, h. And then on the top, this is where it's going to get a bit sticky. Let's zoom in here and really make sure we do this nicely. I'm first going to expand this out. So this is going to be 9 plus 6h plus h squared. Then it's going to be plus 12 plus 4h minus 3. Let me just bring this out a bit more. Then I'm going to keep on going. This is going to be, let me just make that a bit nicer, negative 9 minus 6h minus h squared plus 12 plus 4h minus 3. Then that's going to be divided by h. Now I have to collect some like terms. I have negative 9, I have plus 12, I have minus 3. Negative 3, negative 9 is negative 12, plus 12, they're all going to go away. So this, and this all go away. Then in terms of h's, I have negative 6h, and I have plus 4h. So that's going to be negative 2h. So let me come over here, let me scroll down. I'm going to have negative 2h, and I still have this negative h squared. And all of this is over h. I now am going to take out a common factor of h in my numerator. So it's going to be negative 2 minus h divided by h. Having done that, I can now cancel this with this, which means I'm going to be left with, whoops, let me try that again. I'm going to be left with negative 2 minus h. That is my gradient of the line PQ. Now, what I have to do now, let me zoom out, is answer B. So let me just highlight this. This is my answer. But now what I have to do is, for B, find the gradient of the curve at the point P by considering what happens as h approaches 0. So this is now when we're finding that instantaneous rate of change. So what we're going to do here is go, as my lim of h approaches 0, and I'm doing this for negative 2 minus h, what's going to happen here is that it's just going to be negative 2, because as that h approaches 0, it just goes away, which means I'm just left with negative 2. So that means that is going to be my answer for B. So there you go. There is all the working for this question. Hopefully that was helpful to you. I will see you in the next video.